single factor thinking is the source of the biggest fuck-ups in biology, medicine, and healthcare. So your gut surface, also as we talked about in the previous episode, literally has to pull nuggets of gold and diamonds from a river of shit. There's a massive potential for disaster or almost magic stuff to happen.
Then why are these studies not followed up and practiced in medicine every single day? How much of this methylation, fear-mongering is actually social media?
Lots.
And what percentage would you say?
80% or more. Who shouldn't take creatine? If you just want to be a bit weaker, both physically and neurologically and mentally, then of course be my guest, don't take creatine. I have an immune system where I have an upregulation of IL-6, tumor necrosis factor alpha, interleukin 1A, interleukin 1B. I've done full genetic testing on my own, on myself.
Welcome to the show where we have Umahro again, and here we talk about the gut and the immune axis. The last time we spoke about gut microbiome and you had all of us hooked onto it, and there were a lot of questions saying that we would love to know more. And today we have Umahro, and welcome again, Umahro, for this show. And thank you so much for joining us. Do follow the journey. And I also see that a lot of the viewers are not subscribed to the channel. So please go ahead, follow, share, and comment, because this helps me bring in more health and science-backed approaches to a healthy and a longer life. And also, it helps me bring in a lot more content to you in a much more better fashion. So go ahead, subscribe, and support me on this journey. So last time we spoke about gut dysbiosis and how that affects the microbiota. And today I actually want to dive deep into how the gut microbiome and the immune system are actually correlated and what this means to somebody who's fighting autoimmunity.
Yes.
Right?
Yeah.
For someone who missed part one, can you just give me like a 60-second recap of what dysbiosis actually means?
Yeah. So dysbiosis is that situation where the composition of the 1.5 to 2 kilograms of bacteria and other microbes that live in your gut is sort of off course. So it's changing what bacteria and other microbes are there, but also what they do.
Right.
So, an easy way to think about it, if you have a nightclub, you could have really nice customers who come, they party, they dance,
Right.
they might kiss someone in the corner and have fun. You could also have a nightclub full of unruly people who do drugs, drink too much, are in a foul mood, they get in fights, they want to fight the bouncers, they're rude to the personnel, they don't just use the bathroom when they need to go to the bathroom, right? And so obviously that's going to cause disruption.
Great.
So.
Right. I think that's like a great example of like a gut dysbiosis, right? Now let's dive deep into what everyone, hears about and loves to talk about, the gut immune axis.
Yeah.
I mean, I've heard about the gut-brain axis very, very commonly, and now people talk about it a lot, but not so much the gut immune axis.
Yeah.
And, what is it when you say gut immune axis, basically?
Yeah. Well, I mean, we probably... Let's say the biggest day-to-day influence on your immune system is going to be your digestive tract and your digestive system. First of all, your gut surface, if you go all the way from your esophagus to your anus, that's probably going to be the biggest surface area you have, right? Skin, 1.5 to maybe 2.5 square meters. Lungs, less than 100 square meters in surface area. But the gut... anywhere from, obviously from an infant to a grown-up, anywhere from maybe 30, 40 square meters up to as much, that's again estimated because you can't measure it directly, but might be as much as 200 or maybe in 400 square meters. So we're looking at a surface area that's anywhere in between half a badminton court to several tennis courts.
That's huge.
So that's a huge frontier. And your immune system will always be super focused on all frontiers because that's where bacteria and other pathogenic microbes want to cross. So your immune system... it's obviously going to be really focused on what's happening at the largest border frontier. You have, and then on top of that, your digestive system is chock full of bacteria and other microbes, 1.5, 2 kilograms. So we're again looking at the numbers there. The number of microbes in your digestive system outnumbers cells in the body by at least 2 to 1, anywhere from 2 to 1 to 10 to 1, right? And then on top of that, you have loads of foreign molecules, right, from food and the bacteria produced from gut metabolism. And think about your immune system's primary role is to look for things that are not self, right? Your immune system is super nosy, So it's going all over the place, your immune cells. They will look at things, they will taste them, they will sniff them, smell them, touch them, take a bite, right? And, listen to them. And so every time your immune system encounters something, the first thing it has to distinguish is between self or not self.
Right.
And then after that, if it characterizes something as not self, it has to choose between tolerance or reaction. And reaction would be inflammation. So obviously think about it through your digestive tract. Microbes, all these strange molecules, proteins, gut metabolites, things that are in the food in the first place, and the biggest surface area. So that will definitely get your immune system's attention. And then depending on the composition of those gut microbes and what mood your immune system is in, that makes for sort of a fabulous combination. It also makes for potential trouble.
Right.
Because imagine if your army is patrolling the largest border and it perceives that most of the people on the other side of the border are strange, but not only strangers, but they're also like, I'm not really sure if they're with us or against us. So we'll be more aggressive. We'll, be less lenient. We're not going to be as friendly. We might be rather uncivilized in the way we handle things. And then you'd get that effect, not just in the gut surface, but that sort of also goes back. So imagine in a country, if the border patrol's like, we have all these people coming who are potential terrorists, and we also have people crossing we didn't really check. So we're going to go back to the police and to MI5 or here in Denmark, PET, or in the US FBI, whatever, and say, hey, you better be more aware.
Yeah.
But that could get to the point where MI5 or PET or FBI start terrorizing the population. So rather than finding terrorists and things like that, or bombers in Spain, they're like, we don't like you. We're going to put you through a legal ringer and put you in jail with innocence. So just that thing about that potential. So that's why what's in the bacteria in your gut, what they produce, really has impact on the immune system. And then also the state of the gut surface. So whether you have normal controlled permeability and absorption, or if you have increased permeability. So your gut surface, also as we talked about in the previous episode, literally has to pull nuggets of golds and diamonds from a river of shit. Pardon the language, but so your gut surface is like, oh, glucose, yeah, we'll take some of that. Vitamin D, oh yeah. Zinc, magnesium, manganese, quercetin, yeah, give us some of that. EGCG from green tea, yeah, we'll have that. Some sulforaphane or some other isothiocyanates from the broccoli and the and from the radishes you're eating and the mustard, whatever. Yeah, give us that.
Yeah.
But all these other things, what is it? Oh, there's some cadaverine being produced. Yeah, you actually get cadaverine produced in your colon, and you can sort of imagine where you initially isolated that compound. Yeah, okay, some putrescine. Nah, I don't think we're going to absorb that. We have some undigested food molecules that are seen as strange. And so then if you get increased permeability, all of a sudden the antigen load on your immune system goes up massively, because now you have uncontrolled passage of gut contents right across the border, and your immune system will see that and say, holy moly, what's going on here?
Yeah.
That's a lot of things,
Yeah.
So you almost imagine if you have a situation, if you were working in either company or government organization where people have to send in applications. And so maybe you handle applications for housing support, right? But that will only happen when you're at work, and it will only happen through the normal channels. People will fill out a normal application. They will send it through whatever system you use. Now imagine that people not only send you applications for housing aid, but they also send you application for school aid or for dentist aid or whatever, And they're not only sending it through your work mail, they found your private email, they found your Snapchat, your Instagram, your Facebook, LinkedIn. They send you messages there, and then someone comes at 3 o'clock in the morning, rings your doorbell, and you open the door, and there's just a box of papers filled out. So now you will get to the point where I'm not accepting any applications, and anyone who comes around, my immediate response is going to be, I'll just jab you on the nose, right? So if you get increased permeability, it's just like this constant overload of the immune system. Even if the things that come across aren't bad as such, eventually immune system's going to have had it. I'm going to react first, and not in a very nice way, with inflammation, aggression, and maybe I'll ask questions later. So so just that, you can see there's a massive potential for disaster or almost magic stuff to happen.
Hi, I'm Dr. Sharanya, a medical graduate and a certified physician with a master's in public health and also a master's in functional medicine and bioidentical hormonal replacement therapy. I have always believed that health is more than medicine. It's about resilience, mindset, and the human stories behind every journey. Welcome to Beyond Limits. This podcast brings you conversation with experts, change makers, and everyday people who have pushed boundaries in health, life, and science. From breaking barriers in medicine and science to redefining wellness and uncovering the untold stories of grit. Beyond Limits is about thinking bigger, living longer, and going beyond what people believe is possible. And if you'd like to work with me on a one-on-one or book a consultation with me, you can reach out via the link in the description at the email therealsharanya@gmail.com. It is TheRealSharanya@gmail.com. Let's go beyond limits together. Now that I see that you said there's both disaster and magic stuff to happen, right? How do you actually prevent the disaster and bring in the magic?
Yeah, well, I mean, the first thing to prevent this disaster is, again, to make sure that you create the conditions where you're most likely to have the right microbes living there and acting in a, acting and behaving rather than acting out. And so that comes back to some of these basic lifestyle behaviors. Eat more real unprocessed foods, eat huge volume of plant foods, not just with fiber, but all sorts of other things in plant foods, vegetables, berries, fruits, whole grains, legumes, and so forth, tubers, almonds that feed beneficial bacteria. Make sure you have a constant supply of beneficial bacteria. So eat and drink all these fermented foods, yogurt, kefir, buttermilk, creme fraiche, sauerkraut, kimchi, kombucha, and so forth. So do that just to create better conditions for the right microbes to live and thrive and be fed, and stop all the things we know that sort of in general will cause dysbiosis. So smoking, drinking, modern ultra-processed foods that are devoid of fiber and micronutrients and phytochemicals. Make sure you get enough sleep. Make sure you're not too stressed, and make sure you exercise, not overtrain, but exercise enough. That would help create a beneficial condition, or you're less likely to have things go off track. So that would be the starting point. And we can see in studies, if you have people for immune function, people who eat more fermented foods and greater variety of fermented foods, they generally have a more regulated immune system. Right? So in your immune system, you want this balance between your immune system being really surveillant and vigilant and super nosy, but also probably 99.997% of the foreign molecules it encounters, you say, cool, we're friends, we're going to show tolerance. Like, yeah, we're in Denmark, so we're Jensen, Nielsen, Jørgensen, last name, and Abdullahi, you're from Pakistan, Middle East, South Asia. But you don't have to be at odds. Like, hey, let's have a falafel or, whatever, right? Rather than, I don't know you. I'm just going to start by headbutting you, and then I'll kick you and knock out your teeth. And so you want that, you want that fine balance. And so that's what, if you have very diverse gut microbiome, and you don't have increased intestinal permeability, and you also have your gut microbes, some of the compounds produced by beneficial bacteria actually help shape immune system functioning. So you have all this fermentation going on, right? With your gut microbes, they will eat leftover starches, sugars, fibers, and also some of these polyphenols and other things. And they produce one thing is lactic acid, and we know about that, lactic acid bacteria, but you also have short-chain fatty acids, these other fats. They're not like the fats you find in food, but technically speaking, they are fats. It's especially something called butyrate, butyric acid. And butyrate really helps shift or sort of push immune functioning in the right direction. So butyrate helps promote tolerance and resolution. So it literally, when you have butyrate present, your immune cells are more likely to be tolerant to things.
Right. I think
or show
this is
resolution.
Something that's present in ghee, right?
There's a bit of butyrate in ghee, yes, and in butter.
Because in butter as well. And what are the other foods that are rich in butyrate?
Well, because the thing is, the best way to get butyrate is not to eat foods with butyrate. It is to induce your gut bacteria to produce butyrate. So the largest amount of butyrate in your gut will be produced by bacteria like Faecalibacterium prausnitzii.
Right.
What you have? You have Clostridium butyricum, Butyrivibrio as well. You have Roseburia, and some other. And they live really well off some of all these prebiotic foods. They
Right.
live really well off fructans, so what you find in like Jerusalem artichoke, onions, artichoke, leeks, bananas. They live really well off resistant starch that you'll find in starchy foods that
Yeah.
you have cooked and chilled. They live really well off pectin you find in apples and berries and citrus fruits and zucchini and squash and aubergine. And carrots and tomatoes and pumpkin and stone fruits. They live really well off all the dark polyphenols, like what you find in all these healthy foods that are black, blue, purple, dark brown, reddish brown, and this sort of a deep purple, you say,
Right.
like in pomegranate. And so when you then feed your beneficial bacteria of those, they produce butyrate. So you get way more butyrate from your gut bacteria than you can get through food.
Right. That's amazing.
So if you feed the right microbes, they produce butyrate. And so what butyrate will do in terms of your immune function is it will induce tolerance or resolution. So your immune system also becomes better, saying, okay, we're done fighting, so
Yeah.
now we'll chill and be friends again or
Yeah.
patch up things. And butyrate also changes cell growth. So we know butyrate in terms of the risk of colon cancer really lowers because butyrate helps block or prevent or dampen aberrant cell growth, right? And butyrate, when produced by your gut microbes, it will not just stay in your digestive system, it actually goes systemic. So you can find butyrate in your bloodstream produced by your gut microbes, and it will then help. So like there's a really elegant study done in mice. So we have mice bred to be prone to asthma. And then if you change their gut microbiota towards a higher production of butyrate, and you fed those bacteria fiber that was carbon 13 labeled, so you can follow the carbon, then you can later see, okay, you get these bacteria, they're fed prebiotic components that are carbon labeled, and then butyrate started turning up not only in their stool, but also in the bloodstream that was carbon labeled. So you can see how that butyrate produced by the gut bacteria, and then as it got into the lungs of those mice, it lowered asthmatic activity.
Then why are these studies not followed up and practiced in medicine every single day? Because we have so many benefits.
Yeah. I don't. I think part of the problem is that it's so not just expensive but hard to do really well controlled dietary studies in humans, right? Because you have to control what people eat, and if you think that your child is unruly, then think about how other adults are. You think you can compel them to do anything and control what they do? Nope, you can't.
Yeah.
So part of the problem is some of these studies is just the scale and the scope of doing them, at least, especially if you want like clinical, really hard, pure data, just becomes a major challenge.
Right.
And the thing, part of it is also the healthcare system is set up very much pharmacological or surgical interventions. Like, okay, I can prescribe you this. There's no counterindications. You're male, female. You have this body weight, blah, blah, blah. None of the counterindications. Therefore, we'll start with this dosage. Now, if you were to have someone say, okay, I want you to increase your production of butyrate, so we'll have to have you eat more fermented foods, and then we'll have to have you eat more whole grains, check if you're gluten sensitive, then you can't have those, eat more legumes, and then you have to eat more vegetables, berries, and fruits, and particularly look at some of these prebiotic components, increase the intake of those, and then remember, if you smoke or use nicotine or drink, that will kill your butyrate-producing bacteria, and then you have to do that. You have to do it repeatedly for weeks, months on end before you see a change.
Right.
And you only have 15 minutes for a consult. Right,
That's incredibly challenging.
That's going to be a challenge. And then again, not to be rude, but there are also quite a few patients who come in and say, just give me the pill to fix it. Like there are lots of things you could do, but you have to do them on your own, and they will require changes in diet, lifestyle, behaviors, all these routines you might have to uproot some of those and change them. And, so there's also...
Yeah, that is a lot of effort from the patient side when you talk about functional medicine. But that being said, you've always mentioned that microbes just don't sit there.
No.
Right? They are they make molecules, they
Yeah.
make a lot of stuff, chemicals in the body.
Yeah.
So can we go ahead and talk about what are some of the key players that actually regulate immune modulation in our body?
Yeah, well, definitely butyrate has quite an
Right.
impact. So it's not the only one, but it's a major one. So
But what about the Akkermansias
Oh,
and
you're
the
talking about-
SCFAs and the Tregs?
Oh yeah, but that again, because butyrate. I mean, so we have like the compounds, we have the microbes, and then the immune cells. So butyrate has an impact on T regulatory cells. So butyrate will make T regulatory cells more active, and they're the type of T cells that actually shut down inflammation or say,
Right.
you know what, all those over there might be foreign. They're not all terrorists, so chill out. Now, if there is a terrorist, we should definitely figure out who that person happens to be, or a mass killer, and we'll deal with that person, not everyone.
Yeah.
So butyrate really pushes, an increased number of T regulatory cells that then are able to better control the immune system. So like we will only send out the army when it's truly necessary and appropriate. There's no other measure that could solve the problem.
Yeah.
And we won't go overboard, we will
Yeah.
actually use proper precision strikes and not just a blanket bombing,
Right.
whatever. So, and if you look at some of the bacteria that are key players, the bifidobacteria, and there are many different ones, but the bifidobacteria in general are quite important. Akkermansia muciniphylla, and there's this back and forth Akkermansia, whether it has an impact on its own or whether it's more like, at least partially, it's also sort of an indicator of the state of your gut surface, right? So like both low, really low and really high Akkermansia is associated with digestive problems, but also immunological dysfunction. And so, it's that then that it's more that when you have appropriate levels of Akkermansia, that's just a marker of a healthy gut surface. That might be part of it. But we also know Akkermansia has certain direct effects. And then obviously Faecalibacterium prausnitzii and some of the other butyrate producers have beneficial effects through their production of butyrate. Some of the lactobacilli also are really important. And the other thing with immune function, some of the lactobacilli produce antimicrobial compounds that then
Right.
help
Interesting.
regulate your gut microbiota. So especially Lactobacillus reuteri, right? That it produces reutericidin and other things that literally help suppress pathogenic or dysbiotic
Right.
gut microbes. And so that would work, and also the lactobacilli produce lactic acid, which also helps regulate the composition of gut microbes. You have that going on, right? And then so those are some of the major players. Now, also what's emerging really interesting for gut microbes that regulate immune function is Saccharomyces boulardii. It's not a bacteria, but a yeast.
Yeah.
A beneficial one. So Saccharomyces boulardii.
But how do you get these Saccharomyces boulardii into your diet?
You'd have to take a supplement because it's not readily present. It was readily isolated by Henri Boulard, French scientist, and I think he was in Vietnam, and I think it was actually off the lychee fruit, as far as I remember. So you might get Saccharomyces boulardii if you eat lychee fruit, but otherwise you need a supplement because you have Saccharomyces cerevisiae, which is like yeast, baker's yeast, brewer's
Yes.
yeast, that sort of thing. But boulardii is a subspecies of that with some very particular characteristics.
Right.
So get that would be, and so what we know Saccharomyces boulardii does, first of all, it also helps regulate the gut microbiome, but it will induce more cellular immunity. So, with the immune response, you kind of have, if you put it into very broad terms, you have 4 areas when you have like the conditioned immune response. You have cellular immunity, that would
Yes.
be immune cells going out one-to-one. Then you have humoral immunity,
Yes.
has nothing to do with humor, but antibody-based. And then you have the T3 response or Treg, which is the central command,
Yes.
the army staff, army general saying, nah, we're not going to react, that's cool, don't need to deal with that. Or
Right.
we're done, we'll now retreat or, patch things up with the enemy. And then you also have what's called the Th17 response, and that's the kind of immune response that looks at yourself,
Yeah.
which can be brilliant because finding cancer cells, finding senescent cells, but also autoimmunity.
Right.
And so we know that some butyrate and also some of the other bacteria, they help balance these three. So you get an appropriate Th17 response, not an exaggerated one. You get more T3 or T regulatory activity, and you get a shift from humoral health towards more cell to cell, or that sort of Th1 response. So so those are regulated, and we butyrate, but also some other compounds. Now, what also plays a major role is actually we have all these plant compounds, polyphenols and so forth, but a lot of those only really work once they've been metabolized by the gut microbiota. So beneficial bacteria will literally digest them or turn them into active compounds that then have an impact. So then again, this interplay of having plenty of polyphenols, carotenoids, bioflavonoids, and a diverse microbiota will
help. For someone who's starting off with an autoimmune disease, how would you kind of say that they get to a place where their gut starts metabolizing these things for them, because we also know that initially when people start eating, the gut microbiome takes time to react.
Yeah.
It takes time to develop the diversity. It's like making friends.
Exactly.
You can't make 10 friends in one day.
No.
You would take maybe a month, maybe or two to make these friends, and then you want them to show up every day.
Exactly.
So what's the thing like beyond food and beyond microbiota? Do you also say supplementation?
Supplementation could be worthwhile, yeah. And we know because with probiotic supplementation, now we're getting to the point of species and strain specificity. So you can say, okay, you have asthma or eczema. So we know that these particular lactobacilli and bifidobacteria actually help dampen the Th2 response and upregulate the Treg response. Or, you have some sort of autoimmune disease. These particular substrains help. So, so you get supplementation would make sense as well. Also, prebiotic supplementation. So, either very specific prebiotics, especially if you've done stool testing on someone, so you can see, okay, Akkermansia is low, so we'll give you fructans, we'll give you these dark polyphenols, we'll give you mucins and mucilages because they will help feed or create an environment that favors Akkermansia. Or your bifidobacteria low, therefore you should eat pectin and so forth. So you can both dietary diversification, but also prebiotic supplementation. So that's also if you get to the point where you do stool testing, you can start doing things that are way more focused because you can see gut microbes that are lacking or gut microbes that cause problems. So we know with autoimmune diseases, there's a genetic component. And part of that, some of these genes that predispose for rheumatoid arthritis, ankylosing spondylitis, and so forth, what they will actually do is they will predispose you to sort of skewed reactions to your gut microbiota. So then you have gut microbes, because of your genetics, your immune system reacts in an adverse way to those gut microbes, but it will cause a cross-reaction against your own tissue. So we know not everyone, but a subgroup of people with rheumatoid arthritis, they will hyper-respond to some of their gut bacteria. And so if they then have these gut bacteria, the immune system sees those gut bacteria and then goes, I'm also going to attack your joints. Now, for someone who doesn't have that genetic variation, that won't happen, right? So we know, so there's also, if you start getting to stool testing, okay, so people have this autoimmune disease, they might have either these sort of dysbiotic microbes present, or sometimes you see some of the beneficial microbes that actually could, in people who are inclined cross-reaction. So, when you hear about people who have rheumatoid arthritis, and sometimes they go on a sort of a carnivore diet or a low-starch diet and they get better, that could be because they have bacteria that are normally considered beneficial, but due to their genetics, their immune system gets triggered in a sort of off or awkward way and starts reacting against your own tissues. And so therefore you've starved those bacteria actually by eating a diet that's less conducive to overall gut microbiome growth. And for that patient or that person, that would be better.
That's brilliant, because it just tells us that now we have the nuancity of getting tested. And we have the nuancity of seeing what microbes are beneficial.
Exactly.
And then we can really target and get into personalized treatments, which are what we are ideally aiming to get at with each of our patients. Now, moving forward beyond the food and the microbes, you've also spoken about genetics and methylation as a part of, the gut immune puzzle, right? And it's a very, very important part of it. So how does methylation and genetic difference influence someone who responds to the same gut stresses? That this could be, for example, detoxification, inflammation, or autoimmunity risk.
Well, I think because I think methylation is one thing. We'll just put that aside for a moment. But we know that genetics definitely have an impact. So you have people. One thing, you have people who have these very particular genes that predispose them to either food or gut microbe cross reactions against their own tissue. But the other thing, you'll also find people who just genetically have a very aggressive immune system. So actually, I know for myself, part of the reason I developed multiple autoimmune diseases, I've done full genetic testing on my own, on myself. And part of that reason is because I have an immune system where I have an upregulation of IL-6, tumor necrosis factor alpha, interleukin 1A, interleukin 1B. I have fewer soluble decoy receptors for tumor necrosis factor alpha. So you can have people who genetically are predisposed to have a more aggressive immune response. And then I said, well, your digestive tract is the largest border area and also the place with the most highest concentration of interaction with foreign molecules or antigen. And then if you have an immune system that's genetically predisposed to be like, who are you? I don't like you from the get-go. But I'm actually, I'm not sure so, right? So it's going to take a lot of persuasion, or even with persuasion, it's like, not going to respond, right? So then, therefore, you're more likely to get a reaction. So, so that's definitely one issue. Then the other thing we see is with genetics that we're also now seeing that there are people who have genetic differences in their predisposition for gut permeability. So you have people who are genetically better at maintaining gut surface integrity and therefore having lower gut permeability. And then you have people who are, just at the get-go have poor integrity.
Yeah.
Would be me, by the way. I also genetically, I have to do a lot more to prevent leaky gut. So that could be it. And then also, there's definitely also detoxification, because normally I think detoxification will happen in your liver, your kidneys, but there's also quite a lot of detoxification going on in your gut surface, right? Because you have all these molecules that are produced by gut microbes. You have things that your liver throws into bile that go into your digestive tract that then need to be handled and metabolized. So people who genetically have poor ability in certain parts of detoxification also are more likely to not be able to metabolize or handle some of all these foreign, potentially toxic molecules that accumulate in your gut surface, and therefore you get detrimental damage from those, detrimental effects from those.
Right.
So that could play a role. And there's definitely also some link between some of the genes that impact vitamin D sensitivity or the vitamin D levels, and whether you're more or less likely to hyper-respond to what's going on in your gut. Because vitamin D is so important for immune function. It's been necessary for a proper, robust immune response for true pathogens and infectious microbes, but it's also super necessary for down-regulating unwanted inflammatory activity. So then, if genetically you have a harder time maintaining vitamin D levels, you're more likely to have vitamin D levels that are lower, and then you get a mal-response, so to speak, to your gut microbiota or to foreign molecules. And you also have people who have poor vitamin D receptors. So that would mean it's not the level of vitamin D, but their cells are kind of deaf. They don't really respond very well to vitamin D, and therefore they need higher levels to get the same. If someone's partially deaf, like, you have to talk repeatedly, really loud and slow, and you will have to repeat yourself again. And that's what you meant, right? Whereas if the person has normal hearing, well, do that. Yeah, cool. I'm on with that. That makes sense.
And that also gives us answers to why so many people are deficient in vitamin D even after supplementation. Yeah. Vitamin B12 even after supplementation, right? Yeah,
well, it's definitely the genetics for vitamin D. There are some genes that lower your ability to get vitamin D into the bloodstream, so not necessarily absorption, but then it goes to your liver, and then you also have people who have genetically too rapid metabolism of vitamin D, so the vitamin D gets there, but it's broken down.
Right.
Right. So that's definitely. And for B12 as well, there can be genetic predisposition for B12 malabsorption, which then also gets you in trouble. And actually, low vitamin B12 also impairs your ability to maintain gut integrity.
Yeah.
So there's definitely that. And then because methylation is this, it's almost become this kind of boogeyman in functional medicine.
Yes.
Where it's like everything's and in some ways, yes, everything is related to methylation, because you use methylation for turning on genes, turning off genes, repairing genes. It's one of the many ways by which you can handle toxic molecules, break down things. It's used for the synthesis of carnitine, coenzyme Q10, creatine, some of these molecules for energy production. Methylation is used in the production of neurotransmitters, the breakdown of neurotransmitters, incorporating omega-3 fatty acids into cell membranes, nitrogen oxide production as well, keeping homocysteine levels down, and also in the production of a lot of these structural molecules, collagen, fibrin, elastin. So but it's also kind of, it's gone to point, you have gene variations in methylation, therefore all your health problems must now be due to methylation. So there's something I'm fond of saying, is a bit rude, but single factor thinking is the source of the biggest fuck ups in biology, medicine, healthcare. And people say it's just this thing, methylation or insulin, carbs, or saturated fat. The best thing in the world, the worst thing in the world. Like, you're not seeing the forest for trees. In fact, you're not even seeing the tree because you're just looking at, one branch or one twig.
Right.
But definitely we know people who genetically have poor methylation. It's almost like they can handle less of all sorts of loads, whether it's immune assaults, cardiometabolic, because, as I said, methylation is used to regulate all these processes. So if your ability to maintain proper methylation is less robust, then you start overloading your body, whether that's your cardiovascular system, whether it's detoxification, neurobiochemistry, stress response, maintaining genetic stability. You'll have less capacity before you kind of go above and beyond what you can handle.
No, that's brilliant. And I actually want to ask you this. How much of this methylation, fear-mongering is actually social media?
Lots.
And what percentage would you say?
80% or more, yeah. Because you have all these people again who they don't understand diddly squat about methylation. It's like, yes, something is important, but that doesn't mean it's everything.
Right.
Or then people, if you have a methylation problem, you must eat copious amounts of methylfolate and methyl B12. It's like, actually, if you have poor methylation, yes, you should get enough folate, enough B12. Some of it methylated. You should also get B2 because a lot of the gene variations that give poor methylation, they lower your ability to methylate folate, but B2 is a cofactor, so you can ameliorate a lot of the side effects just by going 2, 3, 4 times RDI of riboflavin. If you have an issue with methylation, you should get enough protein because methionine is used in methylation, enough magnesium, enough zinc. Also get enough creatine because about as much as 50% of methylation capacity is used for creatine production. So if you then get preformed creatine, you have more methylation capacity left over, so to speak. And then also for proper methylation, make sure you get enough choline because you also you can use methylation to create choline, or you can use choline to sort of feed back into methylation.
Right.
Get enough glycine because that also plays a role. And enough B6 because you can also go from homocysteine to the sulfurous amino acid cysteine. So in general, so you have a methylation issue, get plenty of B vitamins, folate, B12, B2, B6. Get enough protein, get some creatine, get some glycine preformed, get some choline preformed, eat foods that are rich in lecithin, that give you lots of choline. And, and then don't overload your body, whether that's in terms of hormone handling, immune response, detoxification, whatever, and you'll be perfectly fine.
Right. This sounds great, but for somebody listening to this, it might seem a lot gibberish because they're like, okay, now I need choline, I need B2, I need B12. What's the single best way to put all of these things together? If I were to say, now that we understand the genetics, we understand the methylation part of it, and you start building an optimization stack per se, right? So let's go ahead and unpack that. And what would be the goal to build this optimization stack?
Yeah. So, well, again, I mean, like foundational health first. Move, sleep, de-stress. Don't smoke. Also, don't use nicotine. At least don't continue using nicotine. If you use that to stop smoking, and don't start using nicotine and say, I'm not smoking, that's good. Eat healthy, so get that tea plate we spoke about earlier with half vegetables, berries, and fruits, 1/4 healthy protein, whether it's plant or animal-based healthy fats, and the last quarter starchy foods. So do that, then get a good, strong, potent multivitamin mineral. That would make sense. Take creatine. So I think that's one of the supplements everyone should be on, not just if you want to be a gym bro or gym brodette, because creatine is not just this muscle, it's also your brain muscle, your heart muscle. I love that you said
this because I have a lot of friends and colleagues who say, I don't want to be on creatine. There's so many studies that say that I'm going to lose my hair. I'm like, no.
Nope.
Can you break that for me?
Yeah. Creatine, losing hair and creatine, there's nothing to it. the notion was that if you take really high levels of creatine, you'd get high levels of dihydrotestosterone. That's been debunked, at least in normal levels. Might be if you take 50 grams of creatine a day. And I've seen that one case. My good friend Anders Nedergaard, who also does a lot of work with health and nutrition in Denmark, and I, at one point we were doing educational for some of the personal trainers in one of the big chains of gyms. And there's this one guy that, then started saying creatine, 5 grams, I felt great. So I thought, okay, I'm going to do 50 grams a day because I'm going to be 10 times stronger and that sort of thing. And he actually started getting, a bit of male pattern baldness. So maybe at really high levels, but at normal intake, no.
Yeah.
And people say, I'm going to get massively muscular. If you do steroids, yes, not if you take creatine. And so when you look at it now with the research creatine, because it's so more than just physical strength, it's neurocognitive function, it's metabolic function, it's immune function, it's cardiac function. So the other way, who shouldn't take creatine? If you just want to be a bit weaker, both physically and neurologically and mentally, then of course, be my guest, don't take creatine. If that's what you can do, whatever you damn choose. But I'd actually say, like people say, vitamin D, probably foundational supplement for most people. Creatine should be in that list as well.
Yeah, I think it's foundationally important that you put it across that way, because it's so important that because creatine helps in your brain function, it helps regulate your gut function, and just your general bodily functions of how your muscles hold water, how your muscles hold glycogen, and so much more.
Yeah, well, because basically what creatine will do is it will increase cellular energy availability. Think about it. When we talk about we're burning glucose and fats, that happens in mitochondria, our little energy powerhouses or furnaces. So you take glucose, you take fat, throw it into your mitochondria with oxygen, you literally have a bonfire, and out the other end comes ATP, adenosine triphosphate. That's our energy, pounds, dollars, euros, rupees, whatever So that's what you used to pay for any type of cellular activity. And once ATP is used, it becomes ADP. So you need to recharge ADP or create new ADP from scratch in mitochondria. What creatine will do is allow you to recycle ADP back to ATP. So you literally, the energy, bills or coins you've created, you can you reuse those multiple times and recharge them with creatine, so you get more cellular energy. And of course, that will impact physical function, but brain function, immune function, gut function as well, because you use massive amounts of energy for everything, peristalsis, production of gut, digestive enzymes and digestive juices, maintaining gut integrity and so forth.
So on top of this that you just told me, right, what are some of the supplements and probiotic strategies, including spore-based products that have earned like a place in your toolkit, and in what kind of cases do you actually use these? Yeah,
so spore-based probiotics are interesting. So they're bacillus, right? Not lactobacillus, but types of bacillus, and they're kind of very old school, but now getting their revival. So if you look at some of the first probiotic products that were available back in the 1950s, they were actually bacillus. And so what bacillus will do is one thing. In general, they will actually enhance the growth of the other beneficial gut microbes. It's almost they come along and say, yo, friends, come over. We're having a gut party down there. Back to the nightclub analogy. It's going to be a brilliant one. We'll only have champagne, not too much, and we'll have healthy snacks and enough water and enough electrolytes so people won't get hungover, so forth. And then bacillus also increase secretory IgA. So IgA is the type of antibody that kind of neutralizes things, so you don't have to deal with it. So secretory IgA, you could almost think of it like a minefield you put, so you never have to deal with the enemy, or you put on, chicken wire fence, whatever, a wall, you have a moat with crocodiles or Portuguese men of war in it, whatever, electric eels, right? So you don't have to deal with antigens, both microbes, but also foods and molecules you're sensitive to. And so if bacillus will increase secretory IgA production, Saccharomyces boulardii will actually do the same. And then bacillus also are really good at competing with some of these unwanted microbes.
Right.
So, the lactobacillus and bifidobacteria, they're great, but, and it's speaking very broad terms, at least a lot of those strains are kind of a bit wimpish. So if they get in there and say, there's some nasty people over there, but I don't really want to go and confront them.
Yeah.
And the bacillus is like, yo, this is our space. Get the hell out of here. I'm going to headbutt you. And then lactobacillus bifida, come over. We've, the playground, we've now gotten, we bullied the bullies away, but we'll be nice to him. The same thing goes for Saccharomyces. So spore-based probiotics are really good. I mean, there's also, just to tell, what will they do for immune function? Christian Hansen, which now is part of Novanensis, their veterinary division, right? And also, in fact, a lot of the research on probiotics happens to start with veterinary research. So they had, really interesting study with pigs that they exposed to the flu. And so they had 3 groups, control group. And so they'd, take like literally spray flu particles into the trout or nose of the pigs. Then they had one group they gave the flu vaccine. Then they had another group where they took bacillus and inoculated them with bacillus in their nose. And the group that got bacillus were as well protected against infection with influenza as the ones who got the vaccine.
That's brilliant, because it now says us a lot more opening into vaccines versus anti-vaxxers and what bacillus and spore-based bacteria can actually do for us.
They can do something, although it's again, because if you eat bacillus, they'll be in your digestive system, so they're not in your nose and in your lungs and so forth. But there's definitely some interesting things mechanistically going on there, right?
Yeah.
So also with probiotics, because usually the products will be lactobacillus and bifidobacteria, but for a lot of people, both for regulating dysbiosis, also regulating immune function, considering Saccharomyces boulardii, and some of these bacillus subtilis, and so forth would also make a lot of sense.
I think that being said, I also have like a great question to ask you. Now, a lot of people come to me with questions of, I have been on antibiotics for the last 1 month, for 2 months. What does that gut look like?
Definitely different, probably somewhat devastated, right? So you'll definitely lose lactobacilli, bifidobacteria. Also, some of the butyrate producers tend to be decimated by, or at least lowered by antibiotics, and you get more yeast. Also, you tend to get more proteobacteria, that group that should be there only in low amounts because some of the true classic pathogens are in there, but in general, they're more inflammatory, right? And so that definitely changed. So if you're on antibiotics, I suggest, when you go on the antibiotics, you should be doing Saccharomyces boulardii. So that will help prevent some of that shift in gut microbiota. The same with bacillus. A lot of the bacillus species are pretty resistant to most of the antibiotics we use. There are particular ones that will kill them, but penicillin and so forth, tetracycline, some of these other things, or some of the macrolides that are frequently used. So they will go there and they'll say, okay, so lactobacillus and bifidobacteria have been decimated, but we'll still protect the space so you won't have annoying squatter-like types taking up residential space, taking over. And also eat lots of probiotic foods. So, we see from studies people who are on antibiotics, if they actually eat kimchi, sauerkraut, yogurt, buttermilk, skyr, creme fraiche, and so forth, they get less of a change in their gut microbiota.
Right.
So that would make eat lots of probiotic foods. You could also take probiotics. Particularly, we know that there are strains of bacteria that help prevent antibiotic-associated diarrhea. So you could take some of those, right? And then also, again, eat lots of prebiotic foods. That will help minimize. Right. And you could also take butyrate, preformed, because butyrate not only regulates immune function, but butyrate also helps prevent overgrowth of certain nasty critters. So there are a couple of studies where they looked at people who were given antibiotics and then nothing, given probiotics, prebiotic foods, or given butyrate. And the butyrate seemed to be as effective in terms of preventing overgrowth of yeast and proteobacteria as probiotic foods or probiotic supplementation.
That's increasingly supporting evidence, right? Because I see people go through surgery, I see people go through a major illness, and then they say, I have constipation now.
Yeah.
And I also see a lot of doctors advising them that if you have constipation, yes, definitely don't strain yourself and try to, get those things to rupture. But then I know people who have constipation for years.
Yeah, and they might be put on, I'm not sure what it's called in the UK, Movicol, which is Macrogol, right? But also just for constipation, movement. So people are physically inactive. They get And we know that ginger is really good for stimulating motility. Kiwi as well. It's really good. Plums or prunes as well. Although you might want to control the dosage.
Yeah.
The other day I had a client, 17-year-old boy, who, well, I think kudos to a 70-year-old who says, I want to do functional medicine. He had severe problems with constipation. So I said, prunes or prune juice. And so he went and he bought a whole bottle of prune juice. And the next morning he drank that bottle and then went to school. And I said, yeah, I didn't have a problem with constipation that day, Umahro. However, I had to be really close to the bathroom. Like, I didn't tell you to drink a liter of prune juice. I said, but that, and also fermented foods, and then also just getting enough fiber. Like the number of patients I see who either have a general problem of constipation or get constipation after antibiotics, whether that's for surgery or throat infection or pneumonia, and then they get constipation. Are you getting 600 grams of vegetables and berries and fruits per day? Nope. Are you getting at least one serving of legumes per day? No. One serving of whole grains? Nah. Getting nuts, almonds? No. Okay, do that and see what happens. And then, 2-3 weeks later, no, I didn't have a problem with constipation.
Yeah, I think that's extremely good to have that assessment, because most people just say constipation and then they forget all the things that they have to do at the background to prevent it, right?
Exactly.
Now, if someone listening to this podcast has issues with autoimmunity, that is, they have Hashimoto's, which we see commonly picking up right now.
Yeah.
Like I see patients and then I just see that anti-TG, anti-TPO right up there.
Yeah.
How can they do something about it with just starting off with their gut? If I would still say, like, start a 7-day gut protocol just to start, what would that look like?
So it's a 7-day protocol, 7 days with no ultra-processed or processed foods. So like anything ultra-processed or processed, bye-bye. So you're going to have to make food from scratch or buy things that have been made from scratch.
Right.
And then go back to that tea plate, half of it vegetables, berries, and fruits. 1/4 healthy protein and healthy fat, 1/4 starchy foods, but real unrefined starchy foods with all the fiber and phytonutrients there. Get at least 2 servings of fermented foods per day in 2 different categories.
Right.
So that would be it. So I would see that if you have for Hashimoto's, that would probably be a good starting point for resetting your gut microbiome, especially with more fermented foods. We can see combined with enough prebiotics by eating lots of plant foods and unrefined foods, that would be a really good starting point for sort of a gut reset for Hashimoto's.
Right.
And then you could throw in some Saccharomyces boulardii, or maybe like one broad spectrum probiotics that has Saccharomyces, Bacillus, and all the usual Lactobacillus and Bifidobacteria.
And my next question would be, can someone actually become superhuman if they were to take these 1 or 2 probiotic supplements? If you were to suggest something that they could just pick off the shelf and say that these 2 things, whether or not you're immune compromised, whether or not you have any of these things, would change how your gut functions?
Superhumans may be a bit of a stretch, but things that would be beneficial for you. So again, Saccharomyces boulardii would be, and if I were forced to choose between Bacillus and Lactobacillus and Bifidobacteria, I'd probably almost go in the direction of Bacillus, because Lactobacillus and Bifidobacteria, they're easier to get if you eat fermented foods and eat or prebiotic foods. So they can actually they're easier to replenish by dietary changes. Whereas Boulardii, as I said, unless you eat lychee from Vietnam, you probably won't get it in food. And then Bacillus as well, they aren't in that many foods.
Right.
So that would be,
your 2 go-to stack. Right. Now, that being said, right, what is something that you're very, very excited for the gut immune response, for the future of gut microbiome, and all things to do with the microbiota?
Oh, what's really interesting are these test modalities where you test in multiple domains. So one thing is to do testing of the actual gut microbiome, what's down there. You can use PCR, you can use good old growth in a petri dish, right? PCR is probably more sensitive. And then you combine that with all these metabolites that are produced by gut bacteria. So you look at short-chain fatty acids, butyrate, propionate, acetate, valerate. And then also look at bile acids, both primary and secondary, because they have an impact on digestion. microbiota immune response, and then you couple that with urine test where you look at gut metabolites in urine, because you'll also get some idea of what's going on in your digestive system by looking at both beneficial and detrimental things that some of these things they produce that on one hand they'll have a local impact, but they will also go systemic and have an impact in your body. So when you start, and it is emerging, so when you couple those, because you get a way more nuanced picture of what's going on, who's there, what are they producing, and also what are they producing that will go systemic.
Right.
So that's emerging now, and there are labs that are beginning to look at, because right now you have some labs that do tests where you have the urinary gut microbe metabolites, and then you have the different stool tests with PCR, good old culturing, microscopy, that sort of, and some of these like gut metabolic things. But if you combine those two, then you start getting some really interesting information.
Results.
So that's, I think that's one really exciting thing. And then all this emerging research we have on postbiotics. So postbiotics could either be foods or supplements with beneficial microbes that are dead, but despite them being dead, they still have effects, because they'll still have, effects on immune function. Even if they're not there, the immune system will recognize fragments of them. And then all these other things, postbiotics, would also be the things that contain beneficial things that have been produced by gut microbes. And a lot of the postbiotics are just old ancient foods. Vinegar.
Yeah.
By the way, probably a way to also this good old, have a sip of apple cider vinegar before meals at least once a day. It's good for your digestion. And for a long time, it's like biochemically, that's just blah, blah, yada, yada. But do remember, one of the major short-chain fatty acids produced in your digestive tract is acetate. So therefore, if you get vinegar, you'd actually get a postbiotic.
Yeah.
So vinegar would be also, think about like sourdough bread, because the bacteria are dead, but all the things they've produced.
And also, I think like Indian foods, like we have fermented batters where we make like dosas or idlis or whatever they're called.
Yeah. That would be kind of, they're like sourdough bread. So some pastry dough-based foods or dishes where it's the dough's fermented, and even though you cook it or bake it and the bacteria die, the dead bacteria still have effects, but also all the compounds they've produced have effects. So that's, it's really interesting what's emerging on these postbiotics, what they do. And some of the ways to get postbiotics is also just to eat some of these pretty, old school traditional foods.
Yeah.
And of course they weren't, we'll make some of these fermented batters or sourdough bread or vinegar because it's postbiotic and it's beneficial for your gut microbiota. It provides things that are also produced by beneficial bacteria. Like, this is a way to preserve food and enhance nutrient availability and get good flavor, right?
Yeah.
So that's really interesting. And then there's all this research still going on fecal transplants, right? And in my opinion, it's too goddamn slow, because fecal transplants can, really make a difference. But at the moment, the only thing where it's really sort of used is for Clostridium, like persistent Clostridium difficile, which won't go away even if you give people vancomycin or metronidazole, and so it works there. But there's definitely going to be other cases, like other digestive problems, and as we spoke about previously, there's that one study from Arizona State University with fecal transplants for people with a diagnosis of autism who also had digestive problems, where 50% had improvements, not just in digestive problems. So, so actually better research on fecal transplants. And I know at one point there was a group that were trying to make a fecal transplant supplement called Repopulate, like repopulate and poop.
Yeah.
So because then said, well, if we can isolate some of these bacteria that aren't in probiotic foods or in probiotics, but that seem to make a difference and are sort of core strains that you find across the board when you do fecal transplants, then we could make it a lot easier, because then you don't have to fiddle about with poo from another person, whether you get it, through an endonasal gastric tube or retention enema or triple coated capsules where you have to swallow a whole lot.
I think that's brilliant. And last question I want to ask you is there a way today we can get people to get a fecal transplant, if you don't have Clostridium difficile?
Well, you have to go or you have to go into private healthcare. I think I'm not sure if they're still operating, but in the UK, there's the Taymount Clinic.
Yeah.
And there are a couple of clinics in other places in Europe, and then there are places on Bahamas, Mexico, and so forth. There are definitely also places I know in Thailand as well, and Taiwan, and Malaysia, and Indonesia, where that's done. Of course, the challenge is when you go in private healthcare, you better find a place with a really good track record and reputation, because fecal transplants also, you have to be sure that whoever is your donor, that they aren't carrying pathogens. Even they might be carrying pathogens that are silent, but then they get into another person. And then the other things that's emerging with fecal transplants, you probably want to get a fecal transplant of someone who's the same biological sex as you are, because we know there are differences in gut microbiota between men and women, just based on the difference we have in physiology and hormones. And so if you want something that looks like you should probably, this is like theoretical, but that would make sense. And probably also, as more things emerge, you might even start saying, okay, so I have cardiometabolic issues, so I probably want a fecal transplant from a donor who doesn't have cardiometabolic issues, or even someone who, in terms of glycemic control and lipid management, is exceptional, because we know there's a link between gut microbiota and all these bodily functions. So we could get to a point, although it take a while, to saying, okay, so you have type 2 diabetes, so we could actually give you a fecal transplant from someone who has excellent glycemic control, and their gut microbes might help facilitate. You still have to emulate their lifestyle. You can't keep on eating croissants and potato chips and that sort of thing.
Yeah, I think that's an amazing thing to have, because today we have the solutions and we have the answers to it. Yeah. And I think we've had like an impactful discussion on what the gut microbiome can do for the immune system. If there's one quick thing that you can say that this is what I would say you should do to have like a good immune and gut immune complex, what would that be? To end the conversation.
Yeah, because one thing is really hard. So then cover your health fundamentals. It's back to movement, exercise, sleep, stress, healthy diet with fermented foods and prebiotic foods, no drinking, no smoking. That, because that's the foundation of everything. Then there are all these particular things we can do, but you need the foundation first.
I think that's an empowering message to send back, because I think we always forget to cover our fundamentals and then go back and say that, hey, you know what? I got a big bicycle, but I've not been doing anything about it. Yeah. But I'd say, actually, I think you should just start with moving 30 minutes and then go on to your bicycle maybe, because then that makes sense, because you've covered your fundamentals now and you can move on to doing bigger, better things. Exactly. Thank you so much. It was a wonderful conversation, and I can't wait to unpack more with you, but thank you for the time, and I'm sure my viewers are going to have a great time listening to you, and so much more. Thank you.
Thank you. It's been such a pleasure.
Thank you.